the Air Force deploys to perform its global mission, the location may be anywhere, and you may get little or no advance notice. Civil engineering prime beef teams must be ready to support such action. In many cases, this will involve moving into an undeveloped or unoccupied area, where you will be required to set up an airfield to support sustained aircraft operations. The types of work you will be required to perform will include troop bed-down and airfield construction, and may range from establishing an assault landing field for C-130 aircraft to upgrading a bare base facility to support modern tactical fighter aircraft. During the early stages of a deployment, all required bed-down assets may not be available. Those that are may not be what you really need to do the job. Tents have a way of arriving without the tent poles. Proper construction materials may not arrive until later in the deployment. And vehicles and equipment required to move boxes and supplies are few to non-existent. This program is designed to help you cope with the unexpected and prepare you for dealing with these shortages. Just as necessity is the mother of invention, the idea of expedient construction evolves from necessity. As a prime beef member, you have received training in your specialty, and you know the right way to do your job. This training and your experience form the basis of expedient construction. Expedient construction methods should be considered as an alternative to normally accepted construction techniques. These methods should only be used when materials, equipment, time, or other constraints dictate it. When these constraints are not present, do it the normal way. In order to be successful, you have to rely on your engineering expertise. You then must couple that expertise with sizable portions of innovation and ingenuity. For prime beef teams to accomplish their expedient construction mission, you as a team member must become knowledgeable of the concepts, techniques, and methods that fall within your immediate career field. You must also familiarize yourself with those that fall within your multi-skilling responsibilities. Remember, expedient construction methods are only a short-term solution. They will probably be replaced with a better or more permanent fix eventually. Also of extreme importance when using expedient construction methods is safety. This must remain a major consideration for everyone. Loss of personnel or damage to equipment can be disastrous to mission accomplishment. When you are faced with an expedient construction situation, you must evaluate, prioritize, plan, and execute. Evaluate the situation. What construction must be accomplished, and what are your available resources? What materials and equipment are available to work with? How many people are available, and what are their skills? Can materials that are in short supply or that are unavailable be substituted with other available resources? Prioritize your actions. What are the most critical requirements? Should efforts be redirected from one activity to a higher priority activity? Can available resources be better used on a higher priority task? For example, personnel and resources may be redirected from constructing a billeting facility to upgrading the Wing Operations Center. Or tentage designed for use as a storage facility may be redirected to provide a fire station. Cannibalization may be used to provide items for more critical facilities. The wiring or plumbing in an unused building can be salvaged and used in a building that will be occupied. Lumber can be recovered for use in other construction. And electrical power can be rerouted from a low-use, low-priority facility to a command and control building. Plan and execute. Careful planning saves time and prevents wasting precious materials. After all traditional resources have been exhausted, your innovative skills will prove invaluable as you plan methods for satisfying a construction need. These concepts should be considered for each phase of expedient construction, thereby ensuring that you have provided the best possible solution in each situation. Upon arrival at your destination, you must focus your attention and efforts on satisfying the most pressing need, human survival. Bed down of initial forces is one of the first considerations you must make. You must provide some type of shelter for yourself and the personnel that arrived with you, and plan for bed down of personnel that will arrive later. In addition to personnel shelters, initial bed down requirements include, but are not limited to, providing potable water, erecting feeding facilities, constructing latrine and sanitation facilities, and ensuring security. Temporary shelters may be required during the early stages of deployment, since tents that are normally used may be in short supply or not available at all. Now is the time to put your expedient construction expertise to work. You will have to scavenge for materials that are locally available to construct expedient shelters. This is where your ingenuity will be of great value. The following are some examples that will perhaps give you some ideas. Use packing crates and shipping dunnage to construct a shelter that will keep out most weather and provide some privacy. Parachutes can be used to provide a sunshade or keep the rain off for a while. The parachute fabric can be used to partition an area for privacy. A lean-to shelter made of saplings and brush woven together and placed against a rock wall, steep hillside, or some other existing vertical surface can serve well in most areas. If you are in an Arctic environment, a snow cave can be fabricated to provide shelter by burrowing into a snowdrift and fashioning a room of the desired size. Slope the entrance upward to ensure the best protection against cold air penetration. The snow cave gives good protection from freezing weather, provides a maximum amount of concealment, and, depending on the consistency of the snow, can be built for several people. A metal culvert shelter can be constructed using many types of scrap metal. Use your imagination. In addition to sleeping, metal culvert shelters can also be used as a bomb shelter or fighting position. It is a well-known fact that we cannot survive for long without water. Few things have greater impact on combat efficiency, morale, and the general health and welfare of combatants. Water is required for consumption, decontamination, sanitation, firefighting, and for vehicle and equipment operation and maintenance. It is absolutely essential that an adequate source of water be established early in the deployment. Rivers, streams, lakes, or springs are common sources of water in most of the world. The capacity of a small river or stream may be increased to meet usage demands by constructing a small dam or reservoir so that water can accumulate. In order to collect the water, you may construct a float-type water intake or a bottom intake. These are only two examples that can be used. A simple sand filter can be constructed to treat water for color or sediment and suspended particle removal. After chlorination, this water is acceptable for use. Once the water has been treated, it may be stored in a wood frame container like this. Other examples of storage containers are a rubber tank with protective tarp, a tarp lining an aluminum or wood frame, and an earth pit storage tank. Distribution from the water storage site to the using facilities is initially accomplished by using water trailers, jerry cans, and water coolers. Essential electrical power must be provided to mission-critical facilities early in the bed-down process. During the initial stages of base construction, electrical power will be supplied to critical airfield and communication systems first, and personnel and support services second. Evaluate the electrical supply situation. Is there an existing source of power that you can tap into? If some sort of electrical power exists, it may be redirected from non-essential facilities to those with a more urgent demand, such as command centers and aircraft control facilities. Electrical distribution equipment can be relocated and reused on higher priority applications. After these options have been exhausted, the use of standard military mobile generators should be evaluated and considered. By dispersing generators and using revetments and camouflage, the survivability of generator sites can be enhanced. In order to maintain health standards, facilities must be provided for basic personal hygiene and to dispose of waste. Initially, deployed forces must construct and use rudimentary sanitation facilities until more sophisticated units and systems can be installed. The most basic latrine consists of digging a pit at least 6 feet deep and 2 or 3 feet wide. 2 by 8 wooden planks are then placed across the pit to form a straddle pit latrine. The earth removed from the pit should be placed nearby so that waste can be covered periodically to control insects and odors. When the pit is filled to within 3 feet of the top, the pit should be filled in with the remaining dirt and a new pit dug. A relocatable latrine looks very much like the old outhouse and can be easily and quickly constructed using locally available materials. Field urinals can be constructed of 2 55-gallon drums by cutting the tops and bottoms out of them and welding them together to end. They are then buried in the ground vertically and filled with large stones to within 4 inches of ground level. Some of the soil removed from the hole is used to complete filling the drums. If you like, you can add some funnels and footboards to fancy it up a bit. A seepage pit is an example of a temporary sanitary sewage system that can be constructed quickly for use by initially deployed troops until more sophisticated material, equipment, and supplies can be delivered. Seepage pits are constructed by digging a pit, filling it with stones, and placing a thin covering or backfill over the top. Pits can be any size. However, since most of the seepage takes place through the walls, several small pits are more efficient than a single large one. Initially, wash and shower facilities may be simple and somewhat crude. When there are no facilities, local creeks, rivers, or ponds can be used until expedient facilities can be constructed. With a little imagination and ingenuity, you can build a shower facility. This one can be improved by using post and canvas or burlap to make walls for convenience and privacy. This is one way to heat water for your shower facility. A simple hand-washing device similar to this can be made of 2 by 4 inch boards, rope, and 2 utility cans. Small quantities of solid waste and garbage may be burned in an Expedient cross-trench incinerator similar to this. During the initial bed down, services personnel will be working to establish feeding facilities for which engineers must provide site preparation. You must supply electrical power, water, and waste disposal. The only major difference in utility support for feeding facilities is in the waste disposal system. A grease trap must be installed between the facility and the septic system. An Expedient grease trap can be fabricated using a drum, as shown here, or by using smaller cans or a wooden box that has been made watertight. It is important that grease traps be cleaned regularly to prevent grease from backing up into the drain system or overflowing into the septic system. In order to enhance the safety of our forces and to protect valuable resources, we must take steps to secure the bases we construct. Access and perimeter security for an air base is best accomplished by using a combination of active and passive defense measures. Passive defense is accomplished by locating a physical protective barrier around the airbase. Even if the barrier cannot stop the enemy advance, it will slow them down and expose the advance to active defense elements. In the early stages of airbase construction, when there are very few resources, you will have to use materials that are available on the site, existing topography, and guard and sentry personnel to provide access and perimeter security. In order to facilitate base operations, access roads will have to be constructed or upgraded. The most expedient type of road is simply a compacted earth or gravel surface. You may construct a timber bridge to span a small stream or gully. It can be constructed with logs found in the local area or large structural timbers, whatever is available. Drainage systems are designed to control the flow of stormwater runoff. Because of limited material and equipment, open ditches are used almost exclusively. Culverts are used to control the flow of water under roadways. There are many types of Expedient culverts. You should use the ones that best fit the applications you encounter in the field. 3 examples of Expedient culverts are the sandbag culvert, the log culvert, and the pipe culvert. Head walls and inlets are designed to prevent roads from washing out around the mouth of the culvert. They can be constructed of planks, rubble, or logs. Construction of Expedient revetments is required to improve personnel safety and protect facilities and equipment from enemy attack. Logs or timbers can be used as a retaining wall for earth revetments. In addition to being used as a support for the soil, it increases the effective resistance of the revetment. The timber may be hard or soft wood, but it should be free of knots and other imperfections that would affect its rigidity or resistance to penetration. When used with earth, the timbers should be treated with tar or creosote to prolong its useful life. The earth berm revetment is a sloped mound of compacted soil with a waterproof coat of asphalt, cement slurry, or sod. Using sod helps to camouflage the revetment. The cut and cover shelter has many uses. It can be used as a living space, protective bunker, command post, fighting position, or storage. It is constructed by cutting into a hillside or embankment. Wood, metal, or concrete can be used to line the walls and support the roof. Excavated material is used to cover the roof. The front wall and entrance is usually sandbagged or baffled. Then sod, matching the surrounding area, is placed on the top and front wall. When additional camouflage is used, the cut and cover shelter blends very well with the countryside. Once these basic survival requirements have been met, you must direct your attention to upgrading the airfield facilities. Since the airfield is the fighting platform used by the Air Force, this is your most important mission. If you are deployed to a forward operating location where there is no hard surface runway, you may need to construct a landing strip that will accommodate aircraft such as the C-130 to allow supplies and equipment to be delivered. A runway of compacted gravel or earth can be used in a pinch and on a limited basis. However, to support modern tactical aircraft, hard surface runways must be provided. A bare-base location will usually have some sort of runway and aircraft operating surfaces in existence. Your task is to ensure that these facilities are usable by our combat aircraft. Runways and taxiways at a bare base may require considerable repair and improvement to facilitate extended tactical aircraft operations. Aircraft operating surfaces can be repaired with AM2 matting, fiberglass matting, or concrete slabs. And you can use AM2 or fiberglass matting to construct an operating surface. Airfield lighting must be provided to support nighttime flying operations. In the event that traditional lighting sources are not available, Expedient systems must be installed. Examples are beanbag lights, smudge pots and signal fires, or vehicle lights. These systems may also be used in the event of a power failure. During the course of the deployment, a continuing effort will be required to upgrade airfield facilities as equipment and resources become available. Once airfield facilities are operational, your attention can return to completing and upgrading bed-down facilities. As improvements continue, water distribution may be accomplished by using pumps or gravity flow pipelines. In the event traditional pipe supplies are exhausted, you may use two smaller parallel pipelines to carry the volume of a single large one. Or you may use flexible hoses or garden hose placed on the ground. Upgrading latrine and shower facilities not only improves sanitation, but has a very positive effect on morale. The pit latrine employs a plywood floor over a pit and provides plywood seats. Fabric attached to posts may be added to form walls, forming a petitioned pit latrine. Here you see an example of an Expedient septic tank and a grease trap system that can be installed for small buildings. A watertight sewer line leads from the facility to the septic tank. This line can be cast iron pipe, plastic pipe, self-sealing vitrified clay tile, or tapered joint fiber pipe. Tanks can be made of many different materials, such as concrete or concrete blocks, asphalt-coated steel, and wood. Initially, most solid waste is burned. However, for the disposal of large quantities of non-burnable waste, sanitary landfills can be constructed. During facility upgrade, electrical distribution from central generation plants may be constructed. The program will stop for you to change the slide tray. Press the restart button when the second tray is in place. The three types of electrical distribution systems are on-ground, underground, and overhead. The on-ground distribution system may be used to satisfy expedient construction needs. Because of the high probability of damage to the cables caused by personnel and vehicle traffic, this system is not practical for long-term use. The advantages of the on-ground system are that it is quick and simple to install, has reduced labor, equipment, and hardware requirements, and when the cables are buried around high-traffic areas, it is reasonably safe. The underground distribution system is more resistant to hostile attack than the on-ground or overhead systems because the cables and most system components are out of sight. However, for fast installation, a trencher is required. In the interest of speed, conduits, manholes, and vaults are eliminated, and the cable is buried directly in the trenches. At locations where cables run under roadways or are subject to heavy vehicle traffic, cable should be placed in conduit. Trenches are then backfilled with sandbags and covered by loose topsoil. In order to speed construction, electrical cables may be placed in the same trench as water lines. Overhead distribution is the most common method of distributing electrical power. However, it is time-consuming and costly to install and requires excessive labor and bulky, heavy materials. It is also highly susceptible to damage from enemy attack. Because of these considerations, overhead distribution is not generally considered appropriate for expedient construction applications and is seldom used. All mission-essential facilities must have backup electrical power systems to ensure that a loss of one power source will not endanger the mission. As centrally generated power is made available, the mobile generators installed initially assume this role. As the population of the base increases and activities quicken, it will become necessary to upgrade dirt or gravel roads to accommodate the traffic. The absence or shortage of adequate equipment and material during the initial construction period may necessitate the use of expedient methods during early road and airfield pavement construction. One expedient method is the soil cement road. Soil cement is obtained by mixing 1 part by weight of Portland cement with 10 parts by weight of dry earth, or 6 parts by weight of sand gravel. This mixture is then placed in a prepared roadbed. As the mixture takes on moisture, the cement will help to stabilize the soil. The landing mat road is another good way to stabilize an expedient roadbed. This is done by placing landing mats across the roadbed. 2x4 lumber curbing is then staked down along both sides of the matting to prevent it from slipping from side to side. Drainage ditches down both sides of the road allows water to drain off. This helps to prevent water from standing on the road, thereby eliminating seepage, soft spots, and voids between the roadbed and the matting. Revetments can be built to harden an existing facility or to provide perimeter security. The following are a few examples of expedient hardening and revetment fortification which can be used during the initial stages of airfield development. There are two types of soil cement revetments. The first is similar to the earth berm revetment. The primary difference is that Portland cement is mixed with the soil. The recommended mix is 1 part cement to 10 parts of soil. The second type is constructed of sandbags filled with a soil cement mixture. As the sandbags take on moisture, the cement sets. This extends the life of the sandbags, which normally deteriorate rapidly in damp climates. Filled sandbags can also be dipped in a thin mixture of cement and water. In order to further enhance base security, upgrade of initial security facilities is in order. The ideas presented here are aimed at vehicular access security. The intent is to slow the vehicle down to permit identification and physical disarming if necessary. The steel hedgehog can be an effective deterrent to vehicle traffic. It is easily constructed, relatively lightweight, and is quickly installed or removed. The hedgehog revolves under a vehicle, either puncturing or flipping it. The tetrahedron may be constructed from various materials including steel, concrete, and logs. It is designed so that a vehicle may get caught in the angles or ride up on the device until the vehicle flips or becomes grounded on top. Channelization of traffic is accomplished by narrowing traffic lanes and creating changes in direction that will make it difficult for a speeding vehicle to pass without colliding with a fixed object. This can be done by using structural or natural barriers on each side of a narrow access roadway. Visual restriction can be provided by walls, obstacles, or natural barriers alternating from side to side of the road, causing a vehicle to turn back and forth to negotiate the roadway. Or by a large barrier that diverts traffic around in one sharp turn. Physical obstructions can be made by using structural or natural barriers across the roadway. However, these must be traversable, such as V-ditches and speed bumps. A simple lapland fence can be used as protection around your fighting position, or it can be installed around the perimeter of the entire base. As equipment and supplies continue to arrive at your deployment location, you can replace the facilities that have been built using expedient construction methods with more conventional facilities. In order for civil engineering prime beef teams to satisfy their global reach commitment, you must remain undaunted in your efforts to provide the very best facilities and support you can to sustain operations of our forces. Much of this work will be done using whatever equipment, facilities, and materials are locally available. In order to be successful, you must be able to draw upon your engineering background and training, and you must exercise a lot of ingenuity. Oh yes, it will require a lot of hard, back-breaking work, too. This is a large undertaking, and the success or failure of the overall mission depends on how well you accomplish your assigned duties. This program is designed as an introduction to expedient construction methods. It should be used in conjunction with AFCESA Pamphlet 93-12, Volume 6, entitled Field Engineering Handbook, Expedient Construction Methods. You may obtain additional information from AFCESA Pamphlet 93-12, Volume 3, Bare-Base Conceptual Planning Guide. AFCESA Pamphlet 93-12, Volume 4, Maintenance and Repair of Expeditionary and Theater of Operations Airfield Facilities. And AFCESA Pamphlet 93-12, Volume 5, Planning and Design, Theater of Operations, Air Bases. These publications and this program are designed to assist you in performing your expedient construction mission. They can't possibly cover every situation you may encounter. However, they may provide you with some ideas and stimulate your thinking.